Okay, so let's do number 10 all the way through. A is pretty easy. B can be a little confusing, but it's honestly kind of easy, to be honest. TBH. So let's look at 10. So calculate the impulse. We know that impulse equals force times a change in time. We also know it's in newtons per second, which makes sense. Force times time, right? So here we go. A 65.8 kilogram halfback encounters a force of blah for blah. Okay, cool. So let's highlight all the numbers that are somewhat relevant. Doesn't mean we're going to use them all, but we're going to highlight what's somewhat relevant. So we got a mass here, we got a force here, and we got a time here. Let's write them off to the side too. Mass equals 65.8. Force equals 1025. And then time equals 0.350. Cool. So we can see that? Yes. Kind of foggy. So we can sharpen that sucker up. Okay, I'll take it. Alright, so let's talk about impulse. We know impulse, force times time. So let's plug it all in. Impulse equals 1025, because that's our force, times 0.35. You can put 0 if you want, doesn't matter. Notice we didn't use mass because that's not the formula. Impulse is force times time. We have everything we need to find the impulse. Okay? So calculate that, and hopefully you get impulse equals 358.75. Easy. Easy, easy. Alright, so let's look at B. B is tricky. B is a little tricky, okay? So let's look at B. A 0.168 kilogram tennis ball encounters a force of 126 newtons. Changes its velocity by this, okay? So let's highlight everything that's something we typically use in a problem, or could be important, we'll say, okay? So it's right off to the side. Let's make our line to distinguish between this problem and that problem. Mass equals 0.168 kilograms. Force equals 126 newtons. And our change in velocity equals 61.8 meters per second. Okay, so remember, it says calculate the impulse. So we know that impulse equals force times time, change in time, right? And I also noticed that we don't have a change in time. So then it's like, well, how am I going to find this? Like, if I have force, I don't have time, like, how am I going to do this? Okay, let's think about this. Remember the impulse and momentum theory, which pretty much means impulse will equal the impulse will equal to momentum, right? So force times time equals mass times the change in velocity. So force times change in time equals mass times change in velocity, where this is your momentum. Sorry, I meant to put a V here. There we go. This is your momentum, and this is your impulse. Notice they give us enough stuff for momentum, but not impulse, but that's okay. So what we're going to do here is we're going to do impulse equals 0.168 times 61.8. Okay, so 0.168 mass times 61.8 some change in velocity. And we're going to get 10.4. Now, this is where everybody pauses and they're like, okay, that doesn't make any sense, because he just said impulse was force times time, yet we just did mass times velocity, and we're calling that impulse, even though that's not impulse, even though it's super confusing. Okay, well, chillax, and let's figure out why. Okay? So again, we know that our impulse will equal our momentum. We know that they give us our force. So I'm going to kind of rewrite this down here super small. You know what? Let's just use another paper. That way we can get big with it. Okay? Let's see. Yeah, that's good. So we know that force times a change in time equals mass times a change in velocity. Now, we also know that our force is 126 times our time, our change in time, equals our mass, 0.168, times our change in velocity. And notice they tell us, changes its velocity by. So this is our change in velocity, 61.8. Awesome. So now that you have that done, if we do our 61.8 times 0.168, I'm going to pause it and give you guys a chance. Alright, so 61.8, I got my calculator up, times 0.168 equals 10.38, which is pretty much our answer, right? There we go. Okay, so let's write that number down, okay? Because again, I know we just did velocity times this, because that doesn't really tell us anything, right? So we got 10.38 about that. There may be some rounding deals where we're off a couple. So remember this number, which is this number, right? So now let's take this. So we know this times this. I'm going to rewrite it. 10.38 equals time times 126, because that was our force. If we divide this over 126, we should get divided by 126, 0.0824. So our time equals 0.0824. This is all extra stuff, right? So now let's take this. So that 0.0824 should be this, right? It is it, I guess, right? So if we do 126 times 0.0824, let's plug everything back in, equals 0.168 times 61.8. Notice, this was what? Okay, this is our velocity, mass, force, time. We already know what this times this is, right? It should be this. Let's do this times this. I'm going to do it on our calculator. Let's see. So 126 times 0.0824. Bam, 1038. Same thing, right? So notice that, yeah, we did it weird because we did our come on, what is it? Momentum, right? But it's okay because if we figured it all out, our impulse should equal our momentum. And there you go. So that's why. I know it's a lot of extra stuff, but that's why we did it kind of weird, right? And I just wanted to prove to you that, hey, it'll give us the same thing. Awesome. That was a long time to do A and B, but that's okay. You guys are worth it.